In this video, we're going to take a look at GeoGebra and how it works in our MA405 Modern Geometry course at Bellevue University. We'll start by looking at our GeoGebra course, both in GeoGebra and in Blackboard. Then we'll take a look at using the web version should you choose to do that. I don't recommend it, but it is an option for you. We'll talk about a basic tools overview, how to create your tool template and continue to add to that as we move through the course. Calculations with GeoGebra, and again, how to display them on the screen utilizing the text box, making an interactive sketch, including checkboxes, and just some tips for success. Let's start by taking a look at our Blackboard course. Week 2 is the first week that you will use GeoGebra, and notice the first thing you should do is sign up for a GeoGebra account. This is a necessary step. If you don't sign up for the account and use that account, every time you click on the GeoGebra course, you'll be signed in as someone new. It will ask you for your name, but it won't save your progress each time that you log in. So make sure that you actually are signed in so that your progress is saved, so that you can get all of the points for all of the hard work that you'll be doing. If I click now on GeoGebra course, it's going to take me to my course, which should look like this. So again, this is all of the items I have to complete for Chapter 1, for Chapter 2, and so on. So before we look at that, I want to look back at Blackboard and look at the homework. So for Homework 2, notice it has instructions to download and complete the attached PDF, and the PDF will contain any proofs for the sections that we cover that week. So this week we're covering 0.9 to 0.11, and then some items from Chapter 1. Most of Chapter 1 is going to be done in GeoGebra because Chapter 1 is about GeoGebra. But if you'll notice, I can click on that Homework 2, and this has all of the information that I need for those sections, the proofs for those sections. But if I click on the actual Homework 2 title and click on the rubric, you can see that the proof homework is 30 points, but that I have 3 points for, or up to 4 points for all of the other items. So you can see exactly what you'll need to do for each of those constructions in GeoGebra. So each of these represent a GeoGebra construction. So for 1.1.1, and again, the rubric is the same for all constructions. 0 if it's incomplete. 1 if the construction you tried but it didn't quite do what you were supposed to do. 2 points for you did the work, but if there was a question that should have been addressed in a text box or some other item that should have been displayed on the screen that you didn't quite get to, you get 2 points, and then 3 points is you did everything as you should. So again, there is no submission when you're in GeoGebra. There's no way to say, okay, I'm done and submit. But obviously you will submit this PDF. So when I'm done, all I will have to do is browse local files and attach that PDF. And then I, as the instructor, will go in and save your progress, or sorry, grade your progress in GeoGebra. So again, navigating in GeoGebra, we're just going to take a look at Chapter 1. So 1.1.1 is the first construction. You can see I already have it done, and we're going to go through some tips and tricks as we move through this video. But again, I'm trying to construct 2 free points. So notice when I say something passes the drag test, this is what I'm referring to. I should be able to move the endpoints of A and B. Point C is a movable point, but it only moves along the line. And point D is not movable because it is a midpoint. So again, this is kind of how we'll go from task to task. Then I will go to the next section and complete whatever items I need to do there, and so on and so forth. So now let's take a look at if you choose to use the web version instead. In addition to being able to access our course through your Blackboard course, I wanted to show you a couple more things regarding GeoGebra on the web. So first of all, if I navigate to geogebra.org, I can actually just sign in with the same account I used to sign into our course. And there I can click on Profile, and under Profile, I can see I can still access that same course that we've been working on. And again, Within those, if I feel like I don't quite have enough room or I want to see it a little bigger, I can always click on that full screen button to make it bigger and then back to smaller again. Now, if you feel like that's not quite enough, I'm going to go back to this page. There is a way to get to GeoGebra on the web. So if I go to Home, I want to point out to you that you should not use this calculator. If I click on Start Calculator, even if I choose Geometry, this interface is different. Now you might say, whoa, I like that one better. And I agree. I like being able to see all of the tools here on the left as opposed to having to choose the correct menu. However, we're not able to use this one as you're not able to create and save tools. So don't click on that one, but you can go to geogebra.org and then classic #geometry, and notice it's a full screen view of the same thing that you would see in our course on a smaller scale. Now you might say, well, that doesn't do me any good because I need it to show up here. So for instance, this one I'm constructing 2 free points and the line segment and a movable point and a midpoint. So if I go to this and I create 2 points and then I create a segment joining them and then I create a point and then I create a midpoint. This is the exact same construction that I just had for 1.1.1. Click back on the Move tool. I can see that it passes the Move test. So if I wanted to do that, I could then go to File and save it as 1.1.1. And if I went back to my course and I went to File, Open, which of course it's not going to work right now, but you would normally see 1.1.1 right here. So I'm not sure why it's not showing up, probably because I'm creating a video, but you get the idea that I could certainly do it that way as well. I could just go to File, Open, and click on that, and it would show up right here, which is where I, as your instructor, will be grading it. So that is another option for you to use that. I don't suggest that simply because it's extra work, because I have to come over here, I have to save it, I have to come back over here, I have to open it, and it's just kind of a pain. So again, I wouldn't suggest doing it that way, but if you really prefer that, feel free to do that. Again, going to that, you can see I don't have this bar on the left, so if you do want to see the bar on the left, you have to go to the little menu and go to View and click on Algebra, and then that will give you this information on the left, which will be important as we continue through this course. Let's take a look now at just some of our basic tools. So I'm going to focus on the tools you'll use quite often in this course. So first of all, of course, you want the Move tool. The Move tool is important because as you're working with these tools, you have to then click back to the Move tool to use it. You can use the Pen tool as well, which obviously you can write on the screen, but quite often it's just not going to be what you want. You can always use the Undo tool, which is very nice to have, so you can undo if you've messed something up. I've used that quite often myself. Obviously, we'll use the Point tool. Creating a point just creates a point. If you create a point on an object, typically GeoGebra is smart enough to place it on the object that you place it on, but if you want to be sure that it's attached to that point, feel free to use Point on Object. So for instance, if I had a segment and then I wanted to be sure that point was on the segment, I could then click on that. But as you saw in the last part of this video, I didn't click on Point on Segment, I just clicked on Point, and it still worked exactly the same way because I chose the segment when I clicked it. Probably you will use, you won't use this Attach Detach point. You certainly could. For instance, if I had a point on the segment and wanted to move it off, I could move it off just like that. But it's not one that you use often. You might use intersect, but you will definitely use midpoint or center, where you're finding the midpoint of, say, a sideline of a triangle. You're not going to use the rest of these. So again, we've already talked about midpoint. And the great thing about GeoGebra is, notice here it says midpoint or center. Let me click on that tool again. It says select 2 points, a segment, circle, or conic. So if I select just the segment itself, whoops, notice I got a little trigger happy on that finger. If I just select the segment, notice it's putting the midpoint at the midpoint of the segment. I can also choose the two endpoints and notice it's created yet another midpoint. So both H and I, which are the same point, which would pass the drag test because as I move it around, that is still the midpoint. In the next options, obviously a line tool or a segment, you'll use both of those quite often. Do keep in mind that often you will need to create a line. The line itself, we might have to create a segment from that line. And the reason that we might do that is if we wanted to clean up something. So I'm going to pop over here to the hide object. So for instance, I might want to hide the two other parts of this line or the other part of the line, which just shows me the segment. And you might be thinking, well, why do I want to do that? I'll show you an example later where we might want to create a line and then hide that line. So again, those are some great tools. That's probably all you're going to use here. In the next one, obviously perpendicular line. If I want to create a perpendicular line, I'm going to use the line and a point. So notice I can move it wherever, but once I click on the point, now it's there. If I click on parallel line, again, I'm choosing the line I want it to be parallel to, and then I can click the point I want it to go through. Perpendicular bisector we will use, and again, 2 points or one segment. So I'm going to choose a segment, and now notice that perpendicular bisector did go through the midpoint, which makes sense. Now, if I tried to do that for the line, it's not going to work because there's no endpoints, so therefore there's no midpoint. So you get the idea. Angle bisector, I don't have any angles here, so let me just put a point right here. And now I'm going to go back to angle bisector, and I'm going to choose those 3 points. And notice this was a 90-degree angle. This just split it down the middle. And a tangent. So let's just make a circle real quick. And then if I wanted to make a tangent, and I'm going to talk about this when we get to the tips and tricks at the end. If I go to tangent and I choose the circle and the point, that's just fine. But here's the problem with choosing the point that I used to create the circle. If I do that, notice it's not just moving that point M on the circle, it's actually moving the entire circle. So again, I'm going to talk about that when we get down to the last part of this video, but don't choose the point that created the circle to create your tangent. Instead, make a point on your object and then use tangent. So here's my circle, here's my line. Now notice on this one, whoops, back to the move tool, this one, the circle is not changing, but the tangent line, the point and tangent line are moving. Obviously, polygon and regular polygon, you will use both of those. Polygon is just any figure. Just make sure you close it. If you go to regular polygon, you're just going to create one segment, and then it's going to ask you how many vertices you want and create the rest of those points. And I want you to notice on the rest of those points that I can move R and S, which were the 2 points that I had created, but I cannot move any of the other points. Circle with the center through a point, you're going to use all the time. So say F, and then I just make the radius as big as I want. Circle with the center and radius, I don't believe I've ever used, but you can obviously use that to make a set radius. Circle through 3 points you may use. So 1, 2, 3. And now it's created a circle through those 3 points. Now again, keep in mind when you create a circle through 3 points, any of the points that you use are going to change the circle. I've never used any of those for this course. Angle, yes, you're going to want to be able to measure angles. So the trick here is to kind of go in the correct order. So notice I went RWV, but if I went VWR, it's going to give me the outside of the circle. So make sure that you're choosing them in the correct order. You can also when you're working with angles, you can choose for it to be 0 to 180. So for instance, let's say I went in the wrong order. Notice, let me move that other dude out of the way. It's now measured 120 even though I went in the wrong order, and that's because up here I chose for it to be 0 to 180, so it was smart enough to know to flip it to that opposite side. So that's a great little strategy to use. This is also where you can very quickly change, say, the color, the type of line, and so on and so forth. You can change if it's just the value, so just the 120, or the name and the value, so beta and 120, and so forth. So that's a great little way to change things quickly. Other than that, yes, you're going to use distance or length. Let me just show you the delete tool real quick because we're getting a little bit crazy. So I can just use the delete tool to get rid, basically an eraser to get rid of everything. Back over here, let's look at distance or length. So let me create a segment real quick. Oops. And then I'm going to go to distance or length. All I have to do is click on the segment and it's showing the distance or length. If I want to choose the area, let's say I'm going to choose a triangle, and then I'm going to create a midpoint. And again, this should be in the tips and tricks, but perhaps I won't even do a tips and tricks because I'll cover it all right here. Let's say I now want to find the area. So according to GeoGebra, to find the area of this is the area of CDE. Notice that's the big triangle. Now, I wanted to find the area of CDF. Now, if I click on that, it's still showing me CDE. And why is that? Because again, according to GeoGebra, I only have one triangle. So I have to create another triangle and another triangle. And again, feel free to make them different colors so that we can see that there's a difference. But now if I click the area tool, I can have the two separate triangles. The rest of those you will not use. We will not do any reflections. We will not use sliders. We will talk about the text box later and the checkbox as well, so we're not going to talk about anything here. And of course, the biggest thing to use here is you can show hide object. So if I wanted to say hide an object or hide a label or whatever I wanted to hide, I could certainly do that. You would do that if you needed that point to create something, but you don't want it shown on the screen because it messes things up. Or I can go to delete everything. And again, I can choose as big an eraser as I want if I'm just trying to erase the whole screen. So that's basically all of the tools. That took a little bit longer than I thought, but hopefully that gives you an idea of all of the things that we will use in this course. Starting in section 3.1, you will need to create and reuse tools quite often. So for 3.1.1, we're going to create a tool that accepts 2 points as input objects and whose output is an equilateral triangle with the given points as endpoints of one side. And then we're going to call the tool equilateral. So essentially what I'm going to do is I'm going to create the object first. So I'm going to create a triangle. Oops, I'm sorry, I want to create an equilateral triangle. So I'm going to create a regular polygon. I'm going to create 2 sides and tell GeoGebra I want 3 vertices. So that's an equilateral triangle. Now to create the tool, I'm going to just go back to the select tool. And quite often, you can make things a little easier on yourself by selecting what you want the output object to be. And you can even change the color. And if you change the color will always be changed when you use that tool, which is kind of nice. So again, I can make this orange instead of blue, but it's certainly not necessary. I can do the same thing with the points and say make them black instead. So you can get as creative as you want. And then when I create this tool, what I'm going to do is I'm going to go to my move or select tool, and I'm going to select the output. I'm going to come over here and go to Create New Tool. So if you don't see it, just click on Tools and then Create New Tool. And notice, because I had already chosen polygon, that is my output object. Output means that's what GeoGebra is going to create for us. I also want it to create point C. Point C is that third point of the triangle. For my input, I just want to create those 2 points. So by selecting the appropriate output object, typically the input objects are going to be filled in for me, but if not, you can always again choose them from the drop-down. I'm going to call this one equilateral. Oh. And make sure that that is filled in. If it's not filled in, it's going to be harder to get to. You'd have to use the input bar to find it, but I'm going to say Show in Toolbar and then Finish. Now, the great thing about this is now I have a tool called equilateral. Now, sometimes it's going to show up more than once. Don't worry about that. I haven't figured out why that happens or how to get rid of it. But what I do know is when I click now on equilateral, I can create 2 points, and notice what happened. It has now created an equilateral triangle with DE as a side. Now, of course, the other way to use that is to use equilateral, if you can spell it, over here, and then you can use the tool. And the tool, oh, I still didn't spell it right, equilateral. And then the tool asks me to obviously create the 2 points. So I wouldn't suggest using it that way. It's a little bit harder. Over here, just click on the tool, and then 1, 2, it makes the 3rd point. Now, I have the tool working the way I want. I've chosen the 2 points. It made the triangle. What I'm going to do is I'm actually going to delete everything on the page, because when I open this file again, I don't want it to show up with all of the triangles already. So I'm just going to go to File and then Save. And I'm going to call this Tools or Tool Template or whatever I asked you to do in the homework. I don't recall the exact wordage. So now I have a tool that works called equilateral, but still on task 28, I don't have anything there. So now I'm just going to use that tool to create the triangle. Then when I move on to 3.1.2, again, it says use the hamburger menu to File, Open the Tools template. So I'm going to go to File, I'm going to go to Open, and I'm going to choose Tools that I just, created. And now, as I can see, I can get to equilateral. If I then want to create my GeoGebra tool that accepts 2 points and output is a square, so again, I'm going to choose regular polygon. I'm going to have 2 points and the output is a square. So here's what my picture is going to look like. Again, if I want to save the tool, the easiest way, this time I'm not going to do that, but the easiest way to do it is to select the square first. But let me show you what happens if I don't. If I go to Tools and Create New Tool, notice there's no output and no input already selected. So for output, I would have to choose polygon and also those 2 points, C and D, that were created for me. Oops, wrong one. If you click on something wrong, you can just delete it. So my other point, my input object, now they've auto-populated for me for point A, point B, and this one is supposed to be called square. So now I'm going to save or finish. Notice up here I've got square and equilateral. I'm going to delete it. I'm going to save it. And then I'm going to use it again to create the square. Okay. I can always move things around to make them work. Now when I go to the next task, of course, I'm going to then File, Open my tools. And I can see that I have square and equilateral already. So the idea is that we're going to continue to build sort of an arsenal or a toolbox of all of the things that we know how to do. So I would continue to create tools as necessary so that later on when we're doing vectin points and things like that that take quite a bit of work, that you have all of those tools available for you. Quite often in GeoGebra, we're asked to calculate certain items, and we really want to be able to let GeoGebra calculate those for us so that as our parameters change, the sum or the quotient or whatever it is that we're trying to compute will change accordingly. So for instance, this is 1.3.3, construct a triangle, find the measures of the three interior angles, and then find the sum of those angles. So I've already created the triangle and measured the three interior angles, which we've talked about how to do already, but we haven't talked about how to calculate the sum. So I'm going to go down to my input box and I'm just going to put equals. And what I want to do is I need to find these special characters. So on the bottom left, there's a little keyboard icon. I'm going to click on that. And typically it's going to take me to this page first. I want to go to the ABC page and click on the Greek letters in the corner. I'm going to choose the alpha, and then I'm going to use my keyboard to add plus, and then I'm going to choose beta, and then I'm going to use my keyboard to add plus, and then of course gamma. Notice that when I do that, I get the sum of 180 degrees. So that's all I had to do for this particular one, is to just find that the sum remains constant. So now I could use the drag test. And as we can see, the drag test, all of these angles are changing, but the sum is still 180, and that's exactly what we wanted to do. Now, for this question, I don't need to do anything else, but I do want to just show you that I could do the same thing, because you're going to be doing this a lot. Let's just create a median. And I'm going to use my, not that tool, yeah, that tool, distance or length. So I can just click on those. That's, oops, no, that's not right. I'm going to find BD, and I'm going to find DC. Now obviously with the midpoint, I would expect BD over DC to be 1, or BD over BC to be 1/2. Well, I can use GeoGebra to find any of those values. So again, BD, and then I'm just going to do the little slash sign on my keyboard. Notice it turned it into a fraction for me. So BD over DC, whoops, DC, and it calculates the solution to be 1, or BD divided by BC calculates to 1/2 or 0.5 as expected. Now, one thing I do want to point out before I finish up this segment of the video, when you create or when you calculate something like this, notice it's given the value E to that or H to that ratio. That's going to come into play later when we start adding those values to the actual graphics display. Let's continue with the same example we were just looking at, and let's talk about how I could add some things to this display to explain what it was that I was doing. So if I go to the second from the right, there is a text box option, and I'm just going to click somewhere on the screen, and that's going to bring up the text box. So if the only thing I have to do is answer a specific question, like we can see the sum of the angles, or the interior angles of a triangle is 180 degrees. So for that one, I chose not to use any special characters or anything. You can always go to Advanced and go to Preview, and you can see that exactly what I typed is what's there. Now, if I want to make it a little bit easier to keep on the display because there's no text wrap feature, I can also use that return button. So now you can see it's a little bit smaller. Oops, I'm going to cancel that. That's what happens when you forget to go back to the move tool before you try to move something around. So again, that's an easy text box, but let's say I'm asked to show that the sum of the measures of the angles is 180 degrees. Well, then I'm going to make a text box, and what I want to do, I'm going to put it down here, and I want to actually show what the angles are. So I'm going to say Latex formula. And down here, I can actually choose items from the Latex formula. You can choose any of these icons as well. So we know I can say sum of triangle ABC is equal to, and then I'm going to go to the GeoGebra tool, and I can choose this first angle plus this second angle of my triangle plus this third angle of my triangle, and then equals, and then I want it to be what did we call the sum of the measures? So notice I'm going to use that same value here. So notice now I have, whoops, again, forgot the move tool. So now I have a great display in LaTeX that says, here's the measure of the first angle, here's the measure of the second, here's the measure of the third, their sum is 180. Notice when I use my move tool to drag everything around, all of those angles are changing, but this is remaining at 180. And it's not remaining at 180 because I wrote 180, but because that is what the actual sum is as computed by GeoGebra. Let's say, for instance, I wanted to, again, show that BD over BC is 0.5 all the time. So again, I'm going to add a text box, and let's say I wanted to say the ratio of the two segments created by a midpoint. We'll do the 1-to-1 is, and then now I'm going to go to advanced, and you can see what the preview looks like. Now, I'm going to have to do some work with some fractions and whatnot. So when I click on LaTeX formula, I want you to see the jumbled mess that this becomes. So when you click on LaTeX formula, it makes the whole formula LaTeX. To create a space, you just do the the backslash and the colon. And so it gets a little bit not awesome if you're going to mix the two, but it's possible to mix the two of your mathematical symbols and actual words or sentences. And again, just as we talked about before, where you're not going to get a text wrap feature, I can just do 2 slashes, and that makes the next line. So by, and then slash colon, midpoint, slash colon, and then I'm going to do slash slash, and then I'm going to look at using the LaTeX formula. So here I want to actually we're going to do BD over DC. So I'm going to choose this, which tells me exactly how to make a fraction. I'm going to replace A with BD and B with DC, and then equals, and then I'm going to do it again, and then I'm going to tell GeoGebra to actually use E, because E was BD. Oh, sorry, nope, just kidding. That was wrong. That's going to be my solution. So let's go back and get rid of that. So I need to use BD and DC, because then it's going to give me the actual values. And then I want the solution for E, which we know is always going to be 1, but again, we don't want to just write 1, we want to let GeoGebra show us 1. So now I'm going to just slide this guy over out of the way. So the ratio of two segments created by a midpoint is, and then I have BD over DC, I have the actual values, I have the ratio, and then those values will change as I use the drag test, but notice that the ratio is still 1. So that should help with creating a text box and actually showing things on your screen. And now let's continue on. Let's take a look now at how to make a sketch that includes checkboxes so that would be interactive in case you were, say, creating this for your own students, where you wanted to be able to allow them to interact a little bit with it without having to construct something from the start on their own. So as you can see, I've already made the construction that includes a triangle. It includes 3 perpendicular bisectors of the sidelines of the triangle and the point of intersection, which is called the orthocenter, which we always call H. Now, what I want to do is have some checkboxes so that I can show little bits at a time. So I'm going to go under the slider menu and choose checkbox. And then I'm just going to choose a position to put that checkbox. Now it says select objects in the construction or choose from list. So unfortunately, I can't like move this to the side, or I could just click on them in the construction, which would be nice. But here I'm going to go ahead and choose point A and B and C. So this is for the construction of the triangle. Notice it says a checkbox for construct triangle. So I want the 3 points and I want the 3 segments. And if I don't choose those segments, then they are, even though I'm still going to choose triangle, if I don't choose those segments, then they will continue to be on your screen if you have the checkbox off. So I need to include everything. And then I'm going to call this construct triangle. So what's going to happen then is when I click on that, whoops, me and my move tool, if I click on the checkbox, notice the triangle goes away, and that's what we want. Now, if you did it wrong, there's no easy way to fix it, so you just delete it and you start again. So I need 1 for construct triangle, I need 1 for construct perpendicular bisectors. So I'm going to make another checkbox, and I'm going to put it right underneath and call it construct perpendicular bisectors. And again, all I want are those lines. So perpendicular bisector, perpendicular bisector, perpendicular bisector. Okay. And then the last one is going to be construct orthocenter. So I'm going to call it construct orthocenter. And then that again is point H. That's the intersection of those points. So back to the move tool. Let's line, oops, I think I'm trying to move. Oh yes, I remember this from before. So there's no way to move it. So make sure you have it in the right spot before you get started. But I have construct triangle, construct perpendicular bisectors, and orthocenter. So again, if I uncheck everything, nothing is on here, which is nice. I wonder if I can actually select and move these. Nope, I can't. Okay, that's okay. So what I'm going to do then is now show how I would construct the triangle and construct the perpendicular bisectors and construct the orthocenter. Now, if I were doing this for a class, trying to take a classroom full of students through something like this, you could also create a text box where you talked about here's how to do everything. Whoopsies. I clicked on something I shouldn't have apparently. Let me try that again. So I could create a text box and I could include to create the triangle and then say how to create the triangle. And then what I would do is in the checkbox, I would include this to be visible. Probably this would be visible right away, but then to construct the perpendicular bisectors, I would have some box like this that would show up after I've constructed the triangle. So when I click construct triangle, it would then pop up and say, now to construct the perpendicular bisectors, do this. And then you would click on it and the perpendicular bisector would show up. The other thing would go away and you would have instructions on how to do the orthocenter. Lastly, I just want to take you through some tips on how to be successful, things that maybe aren't explicitly laid out for you in the instructions, but hopefully you're able to figure out on your own. For instance, this is 1.3.2. We want to construct a pair of parallel lines. So if I create a line, and then, oops, let's get rid of that second guy. And then I want to create a line that is parallel. I'm going to choose the line and choose the point. Now notice point C is the point that I created. It says construct a movable point A on one line and construct points B and C on the other line. So as you can see, when I did this, A, B, and C are already taken. Now I want A to be a movable point on a line. Now I can't make this that line or that point, because if it's not a movable point on a line, it's moving the entire line. So I need to create another point, and I'm going to call that point A because it says call it point A. So that is what I will do. So I just right clicked on that point to call it A. Now notice the former A has turned into A sub 1. That's not a problem. I'm going to change that in just a moment. So I have a pair of parallel lines, a movable point A on one line, and B and C on the other line. So now I've already got a B. I'm going to rename this C. And then I'm constructing a triangle and measuring its area. So I'm constructing ABC. So again, what often students do is they use C as that point. Well, I don't want that point to be even in the way. So what I'm going to do is I'm actually just going to hide that because I don't need it to move anymore. So now I just have ABC. Now it says construct the triangle. So now I'm going to connect the 3 points. And now I can see that I can drag point A. And it says, observe that the area remains constant. Well, how am I going to do that? Of course, I'm going to find the area. I'll leave that for you to do. But again, notice B is going to move and C is going to move, but I'm not asked to move B and C. I'm asked to move A. And it's very important that A moves along the line, but doesn't move the line itself. So again, make certain that the point moves, but the line does not. And then of course it says, can you explain this? So I would use my text box to explain it. We're going to skip over that one that we've already talked about together and look at 1.3.4. And in this one, we're looking for an exterior angle and again, looking for the sum. So just as before, I would create a triangle and I want to measure angles. And remember, if that angle doesn't work the way you want it, you can pop it over to the other side. Same thing here. I'm going to measure this angle. And now what I want to do is look at the exterior angle of the triangle. And so I'm going to create a line because I want the exterior angle over here. I need to put a point over here, otherwise I don't have a way to measure the angle, so I'm just going to put a point over here. And then I'm going to measure this angle as well. And again, notice that GeoGebra has been nice enough to name those angles for me. And what I'm trying to do is show that the sum of these two is equal to the exterior angle. So of course, I would use my input over here to find the sum of alpha and beta. And I'm not going to do this whole question for you. I'm just going to kind of show you how to get started, alpha and beta. And then I would create a text box that talks about the fact that these two angles are going to be equal to the sum of the exterior angle. And just as we did before, I would use that text box. Okay, it's being crazy. I would use the text box to use the Latex formula to choose the alpha plus the beta is equal to the, I believe, gamma, and somehow show that those are going to be the same. And then of course you can show even when moving around any of the points. And if it bothers you to have this whole line here, you can always create a segment. Sorry. Oh, that is not what I wanted to do. Use the undo button. There's another trick. Create a segment from C to D and then hide that additional line. Not necessary unless, you know, you're OCD and want to make sure everything looks as it should. So there we go. We've got our two interior angles, we've got the exterior angle, and we've got everything. And then you would obviously use your text box to talk about that relationship. And again, the only thing I wanted to talk about here is, again, when you're constructing a circle and you have 3 points, when you create the circle, so what I see a lot of students do is say a circle through 3 points, and then they create 3 points, A, B, C. But what happens is when I'm now trying to drag A, notice the whole circle is moving around. Well, I don't want A, because I'm asked to drag A. I don't want A to be one of the 3 points that made the circle. So feel free to add another point A, and then of course you would rename it A. Oops, I think I did something wrong. Oh, I see. Let's just scratch that and do that again. Let me just go to rename and call it A, and then we'll call this guy D. And then again, I should be able to drag A without the circle moving, but just A moving. So I'll let you do the rest of that question as well. But again, if anything ever seems wonky, go back and use the undo button, reach out to me, let me know whatever it is that you need help with. That's why I'm here. So I want you to be successful. Just make sure that you're always using that text box to explain anything where it says, what happens? Observe what happens. Even if it doesn't explicitly say that you should talk about what happens, you should answer any of those questions or musings on your GeoGebra construction.